factoring is basically just the opposite of the FOIL method. So instead of multiplying two sets of parentheses together, we are trying to break this down into two sets. So we'll start out with just placeholders basically. And we know that our first term in FOIL will be the first times each other. To get to our first term here, it's an x squared. The only thing that you're going to multiply by itself is an x. So we go x here and x here. X times x is x squared, so that's a nice simple start. Then we look at our last term and we see what could be multiplied to equal 21. It could be 1 and 21. It could be 3 times 7. So then we have to see which combination of these numbers we could use to get the center term, -4. So if we go 1 plus or minus 21, that does not equal 4 or -4, anything close. So we look at 3 and 7. If we say -3 plus 7, we get -3 plus 7 is a +4. If we say 3 minus 7, or 3 plus a -7, we get -4. And we know that it has to be one negative and one positive. One positive, one negative, because our last term, the sign stays with it, and so it's a -21. Negative you can only get with one negative and one positive being multiplied by each other. And then our center term is where we add. So multiply for this one, add for this one. These are our magic numbers. Remember that the sign stays with them, so -7, +3. Then, if we want to go through and double check, we can use our FOIL method. First, outer, inner, last. First, x times x is x squared. Outer, x times -7 is -7x. Inner is +3 times x is +3x. +3 times -7 is -21. Simplify that. -7x plus 3x gives us -4x minus 21 is the same as what we started with. So we're good. Another example. This time we're starting with a coefficient that is not 1. So we get a little bit more tricky. Again, you set up your parentheses. This time, what do we multiply by each other to get 3x squared? Well, we know it's still going to have to be an x and an x, but there's a coefficient. X times x is x squared. 3, we look at, break that down. The only things that can be multiplied are 1 and 3 to get 3. That's a prime number. So 1 goes on one of them, and 3 goes on the other. Then, same as before, we look at our last term, and we're going to break that down. So 45, you could get it by doing 1 times 45, maybe 5 times 9, or 3 times 15. But now, when we are factoring, we have to remember that they're going to be multiplied by these 3x and 1x. So we have to incorporate that and see if 3 times 1, or maybe 3 times 45, and 1, added or subtracted, will equal our center term. 3 times 5, or 3 times 9 maybe, and 3 times 3, or 3 times 15, and 3. So, shoot these over so we can simplify this a little bit. We have 3 and a 45. Let's see, 90, 135, and a 1. 15, 9, 9 times 3 is 27, 5, 9, 15, and 45, and 3. Again, we're looking for this center term. positive 22. We know that one number in each set has to be negative because a negative 45, that stays with it. So if we have negative 3 plus 45 or positive 3 minus 45, will that get us to 22? No. It's too far off. 135 and 1, too far off. Added or subtracted, these are not going to equal 21. 15 and 9, well, those are both less than 22, so what if we added them? 15 plus 9? Well, even then, we can't do it because one of them has to be negative, so either we start at negative and add 9, or 15 minus 9, we're going to end up less, so that's not an option. 27 and 5, well, if we have 27, that's bigger than 22, and we subtract 5, that actually gives us 22, so we could have a positive 27 minus 5, 7 minus 5, 22. And that's good. We wouldn't want to reverse it because a negative 27 plus 5 leaves us in the negatives, and this number is not negative. So this is a good option. Again, 9 and 15, we have the same thing as before. We know that didn't work, so this isn't going to work no matter which order we do it. And 45 and 3, those numbers are too far off. Even 45 minus 3 doesn't get us anywhere close. Therefore, negative 27, or positive 27 and negative 5 are our options. Now, before placing them in the equation, we have to see which one goes where. We know that 9 is actually the number that needs to get punched in, not 27. 9 needs to be multiplied by 3. So where is 9 going to be multiplied by 3? It's not going to be multiplied if it's in the same bracket. It has to go in the opposite bracket. So we put our 9 there. So we're going to have a 9 times 3 action, just like here, to get the number we need. And 5 stands alone, or is being multiplied by 1, if you want to think about it that way. And then we place our signs. We know that the 5 is going to be our negative term, and this is going to be our positive term. Again, if we want to check this out, we do a FOIL first. 1x times 3x is 3x squared. Outer, negative 5 times 1x, negative 5x. Inner, 9 times 3, there's our 27, it's positive. And then last, it's a negative times a positive, gives us a negative number. 5 times 9 is 45. Combine these two terms, so we end up with 3x squared, negative 5x plus 27x gives us positive 22x minus 45, and that's our answer. Lastly, this gets even more confusing if the coefficient of our first term is not a prime number. So we can start over here looking at 15. Possible combos are 1 and 15, 3 and 5. So we set up our bracket, same as before, but we don't know which is going to be the best coefficients. We know that it's going to be an x and an x. Past that, we are not sure. So we're going to set it up with different options. I'm going to go through and say it could be 1 times something in 3 different situations maybe, or 3 times something, and then 15 is its partner, so 15 times something, and 5 times something. Now we're going to look at our last term, just like we had before. It's a 4. The only thing that can be multiplied to get 4 are 1 and 4, or 2 and 2. So then we set these up, and we know that what's going to happen is that these coefficients are going to get multiplied by these second numbers. And so we have to check all the possibilities that would bring us to add to this. So we're multiplying for this, and we're adding or subtracting to get this. And this is a multiplier that gets this number even bigger. So we're going to start punching in our possible options. When we multiply these, it could be 1 and 4. It could be 4 and 1. Or it could be 2 and 2. These don't have a switch because they're the same. Again, down here, it could be 1 and 4. It could be 4 and 1. Could be 2 and 2. Knock these over and we'll see what we have. So we have a 1. 15 times 4 is 60. 1 times 4 is 4. And 15. So is 2. 30. 3 times 1 is 3. 5 times 4 is 20. 12. And 5. 3 times 2 is 6. 5 times 2 is 10. So these are our end result numbers. Now we have to look at either adding or subtracting these black numbers to get a -4. Remember that your sign stays with it. So -4, 60 and 1, plus or minus, these are not going to give you -4. So this group of combination of numbers is not your answer. 15 and 4. 15, even if it was negative, say -15 plus 4, that's not going to get us to -4, it's too far off. That's not your option. Again, we're looking for one positive, one negative, because this is a subtraction sign here. 30 and 2, -30 plus 2, no. -2 plus 30, way too far off, not our option. 20 and 3, -20 plus 3, we're still way too low. 12 and 5, well these numbers are closer, so maybe we have a -12 plus 5. Nope, it's only -7, still too low. 10 and 6, if we have -6, positive 10, nope, that gives us a positive number, but if we have a -10 and a positive 6, we end up with -4. -10 plus 6 is -4. Which means that this is our good answer, which means that these are good combinations. So we have to make sure that our combinations are flip-flopped. Our red numbers, 3 and 5, those are going to go in the first position next to the x's. So put 3 on one side, 5 on the other. Then we look at our 2. These don't actually matter in this case because they would be the same in either direction, but we place those and we have to make sure the negative goes on the correct side. The negative needs to go with what equals 10. 5 and 2 is 10. What's get multiplied here is this inner term. So 5x times -2. That means our negative sign goes there. 3 is going with that 2 for our first. That's a positive. Now if we want to check this, 3x times +2, we get, I'm sorry, first we go here, 3x times 5x, 15x squared, outer 3x times +2, so it's plus 6x, inner -2 times 5x, -10x, that's the number we're looking for, and then -2 times +2 is a -4. Combine your terms, 15x squared, +6 minus 10 gives us a -4x minus 4, and that's the answer we were looking for.